In the last lecture, we had discussed that one can use a Price-Winston transformation also, and the challenge there was how to estimate rho. So in this lecture, we'll discuss how we can estimate rho for the Price-Winston transformation, and the first way would be to assume that rho is equal to 1. Okay, to remember that rho is nothing but basically a coefficient of autocorrelation, and the value of rho will be between -1 and +1. Okay, so one can assume the value of rho to be equal to 1, and rho equal to 1 is commonly used in fact in several economic time series, and you can simply proceed to the previous transformation. Okay, the second one is to use rho from the estimate of rho from Durbin-Watson statistic. Durbin-Watson statistic. So if you remember, we had said that for large samples this result holds true. So it's D is approximately equal to 1 minus rho of hat. So rho of hat is basically the estimate of rho, that is the true measure of the autocorrelation coefficient. So we can simply find rho hat as equal to, not equal to, as approximately equal to 1 minus d over 2. There is one more method to find to estimate rho, and if you remember, the AR1 scheme looks something like this, but you must also remember that we rarely observe this equation. Why? Because these are disturbance terms from the true population regression function. Okay, we estimate the population regression function, and then we can look at the residuals, and they look something like this. Let's call this V hat instead. So what one can do is simply regress ET over ET minus 1 and find an estimate for rho hat. Simply use OLS technique to regress ET over ET minus 1, and you'll have the measure for P hat. Okay, and there are a few more other methods as well, and I'll just quickly walk you through them, but they are not given in much detail in your text, so I'll just name these methods and then we can close the session. So the first one is the Cochrane-Orcutt two-step method. Let me call this A, and then there is another one called same authors, Cochrane Orcutt iterative procedure. Iterative procedure. Then there's something called Durbin-Watson two-step method. Another one is the Hildreth. Now all these fancy names they are given in your text, but they haven't discussed them in detail, so that's why we have put them. And the last one is the maximum likelihood method. Okay,